Hey guys, welcome back to my channel, and this will be on the series of binomial theorem. But we're talking about Pascal triangle, which is the fundamental of binomial theorem. So Pascal triangle is like a triangle that consists of the coefficients in each powers of binomials. So let's start with that. So what do we mean by Pascal triangle? We start with the words. So it's a triangle that contains the coefficient of powers of binomials. So let's try to generate some values of Pascal triangle. Let's start with that. So when you are doing a Pascal triangle, you start with a 1. Then when you start with a 1, you put a 1 here and a 1 here. So a 1 comes here, a 1 comes here. Are you getting? Then the next thing is you keep on adding the numbers above in the middle. So here is 1 plus 1 is what? Is 2. Then you put 1 to the edge, you put 1 to the what? To the end. Then you go to the next one. So this will be our first one. So this is a what? The coefficient of power 1. So this will be the coefficient of power 1. This will be the coefficient of what? Of power 2. Of power 2. And this will be the coefficient of what? This is coefficient of power 0. This is power 0. This is power 1. So this will be the coefficient of power 2. So Pascal triangle is like what? This, and you can see these three things will be the coefficients when you expand a binomial in power of 2. That means now how do we get this thing? So the first thing you do is what? Make sure you write 1 to the side, 1 to the side. Then you add it. So 1 plus 2 is what? Is 3. 2 plus 1 is what? Is 3. That is 1, 3, 3, 1. This will be the coefficient of power of what? Of 3. So you can see I have 1 plus 2 is 3, 2 plus 1 is what? Is 3, and you have 1 to the inside. What you do again? You add 1 here again. 1 plus 3 is what? Is 4. 3 plus 3 is what? Is 6. 3 plus 1 is what? 4. And 1 is what? 1. So you can see you add up, you write this, you add it up, and you put 1 to the edges. So next one will be what? I'll put a 1 here, I'll put a 1 to the edge. So you can see you have a what? A 5. 1 plus 4 is 5. 1 plus 6 is what? Is 10. 6 plus 4 is what? Is 10. And this is equal to what? 5. So you can see the next coefficient is what? For power of 5, this is what? Power of 5. It's power of what? Of 4. Power of 5. So this should be the what? Should be the coefficient. The coefficient. This should be the coefficient of power of 5, of power of what? Sorry, of power of 4 and power of what? Of 5. You can continue to what? To generate each sequence of what? Of coefficients. Now for this, for the next power of 6, that what? 1 plus 5 is what? Is 6. 5 plus 10 is 15. 10 plus 10 is what? Is 20. This plus this is what? 15. This plus this is 6. And you have a what? You have a 1 to the edges. Now, why do we call it Pascal triangle? We call it Pascal triangle because it forms a triangle. You can see, take it, let's look on like this. You can see a straight line that connects the ones. Can you see that? And also a straight line that connects the ones. So what does it look like? Just like what? Just like a triangle. You can see, let's trace it out. You have something that goes like this, connects, and that gives us a what? You can see, give us the shape of a what? Of a triangle. So that is the reason why we call it a Pascal triangle, because it generates the values of the powers of binomial expansion. So whenever you expand a binomial, the coefficients of the expansion are what? Are encoded in this diagram. So you can generate more and more. You can generate for powers of 7, powers of 8, powers of 9 by what? By adding it up, like that, and continuing what? Getting the what? Each coefficient of powers of binomials. So now from there, since we now know the value of this, we can use it to what? To guess the coefficient of what? Of binomial expansion. So from there we know we have a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1 plus 2 is 3, 2 plus 1 is 3, put 1 to the edge, put 1 to the edge, 1 plus 3 is what? 4, 3 plus 3 is what? 6, 3 plus 1 is what? 4, and you have a what? You have a 1. Now, to be sure we are correct, let's test it. This is the power of 3, power of 3, power of 1, power of 4, and this power of 0. Let's check this. Let's test it out. You see. Let's assume I have a plus b is equal to a plus b means binomial. This whenever you see something like this, two objects by means two, so binomial. And let's expand it. Let's check it out. You have a plus b times a plus b. When you expand it, you have a times a is what? A squared. A times b is what? AB. B times a is under what? AB, and this gives us what? B squared. Doing that, we have a squared plus what? 2ab plus b squared. So you can see you have x squared plus 2ab plus b squared. Now, what do you observe here? You can observe that there's a what? I think value, which is what? An invisible one here, a 2 here, and another what? Another 1 here. So you can see you have 1, 2, 1. 1, 2, 1. Which is encoded in this diagram. You can see 1, 2, 1, 1, 2, 1. Now, what do you observe? I said this is a what? A Pascal triangle of power of 2. You can see P2. You can see this is a what? A power of 2. So you can see they are what? They are related. So that means Pascal triangle encodes the coefficients of an expansion of a what? Of a binomial in a particular, for a particular power. So you can see you have a 1, 2, 1. Let's try for another one. Let's try for powers of 3. So I'll turn this off. Powers of 3 means a plus b squared times a plus b. It means a plus b in 3 places. Now when you expand it, you should get a squared plus 2ab plus b squared. When this and this, you have an extra a plus b here. Then let's go on to that. You have a what? A, this you have a what? An a cube. You have an a squared b. You have another 2a squared b. You have 2a squared b. You have 2ab squared. 2ab squared. You have another ab squared. And you have a what? A b cube. You can see b squared times b cube. That means b in 3 places. So now what do you observe here? You have what? A cube. You can see you have an a squared b here and a 2a squared. They are like terms. So that becomes what? 3a squared b. Next one, you have a 2ab squared and an ab squared. You have another what? 3ab squared plus what? B cube. So you can see you have a 1, 3, 3, and 1. You can see there's an invisible 1 here. There's an invisible 1. So you have 1, 3, 3, 1. What do you observe? This is the power of what? Of 3. Check out the Pascal triangle. You have the same thing here. You have 1, 3, 3, 1. Can you see that? You can see the value of this, the coefficient of each terms in the expression of a binomial of power of 3 is encoded in the what? In the Pascal triangle for the same value. You can see 1, 3, 3, 1, 1, 3, 3, 1. So that means Pascal triangle is a what? It's an easier way of what? Of getting the coefficient of the terms in the expression of a binomial related to a what? A power. So after this, I think you now have the what? Understand the concept of what? Of Pascal triangle. So it encodes the coefficient of the powers. So you can try for what? For powers of 4, you get 1, 4, 6, 4, 1. I think let's try that out. Let's take it out. What does it mean? So that way, a plus b and a plus b, and a plus b, and a plus b. So you can see here, when you do this and this and this, which we've done before, because this is 3 powers, so we have a cube plus 3a squared b plus 3b squared plus b cubed. This 3 gives us this. And there's an extra a plus b. This a plus b, this is it. This a plus b is this, but this 3a plus b is this. So therefore, now let's now open it. So this will be this a cube times a raised to power 4. A this time this is what? A cube and b. This and this is what? Is 3 a cube b. You can see a and then 2. That makes 3. 1 plus 2 is 3. You have this and this. You have 3 a squared b squared. 1b and 1b, that makes 2. 1 plus 1 is 2. This you have 3 a squared b squared. A twice, that is a squared. A times a is a squared b squared. So 3a squared b squared. Next one is 3ab squared times b. You have 2 of b, have a single b, that makes what? 3ab cube. Next, you have a b cube times a. You have an what? You have an ab cube. And this you have a what? A b raised to power 4. That means you have a what? A raised to power 4. Now this is like times here. That makes what? 4a cube b. You have a what? You have a 6x squared b squared. They are like terms. Here also they are like terms, which is what? Which is 4ab cube plus b raised to power 4. What do you observe? You can see there's an invisible one here. So there's a 1 here, there's a 4 here, there's a 6 here, there's a 4 here, and there's a 1 here, which is also encoded in the Pascal triangle for power of 4. So you can see, without expanding this, I can expand it using Pascal triangle. So you can see this is a proof for what? For Pascal triangle, because it proves that the coefficients in the Pascal triangle are the same in the what? Expansion of binomial of power of 4. Then let's now know how to apply the Pascal triangle. Let's start to apply the Pascal triangle. In that case, let's know how to generate the powers of 8. So, for powers of 8, for P8, how do I do that? That means to be what? To be 1, 5, 1, 5, 10, 10, 5, 1. That is powers of 5. Let me write it here. Powers of 5 is 1, 5, 10, 10, 5, and 1. That means here will be what? 6, 15. 10 plus 10 is 20. You have a 15, you have a 6, and you have a 1. That will be for what? Power of 6. Power of 5. Powers of 5. So that means for the I'm looking for power of 8. 7, 21, 35, 35, 21, 7, and 1. So this is what? Power of 7. That means the question is what? Find the Pascal coefficient of what? Of power of 8. That will be what? 1 plus 7 is 8. 28. This is what? 56. 70. 56. 28. 8 and 1. So that means my answer is what? My answer is 1, 8, 28, 56, 70, 56, 28, 8 and what? And 1. That will be the Pascal coefficient of what? Of powers of 8. See you in my next video. Thank you.